January 28, 1986. The Space Shuttle Challenger is getting ready to take off from Cape Canaveral, Florida. This Space Shuttle mission, named STS-51L, is the 25th Space Shuttle flight and the 10th flight for Challenger. Most notable amongst the crew is astronaut Krista McAuliffe of Concord, New Hampshire, winner of a national selection that began in 1984. McAuliffe is to spend at least 2 lessons in orbit, and then spend the following 9 months lecturing students across the United States. The goal is to highlight the importance of teachers and to interest students in high-tech careers. Other members of the crew are Commander Francis Dick Scobie, pilot Michael Smith, mission specialists Ellison Onizuka, Judith Resnick, and Ronald McNair, and Hughes aircraft engineer Gregory Jarvis. The mission experienced trouble at the outset, as the launch was postponed for several days, partly because of delays in getting the previous shuttle mission, 61C Columbia, back on the ground. On the night before the launch, Central Florida was swept by a severe cold wave that deposited thick ice on the launch pad. On launch day, January 28, liftoff was delayed until 11:38 a.m.
We have main engine start, 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Control program. Roger, roll, Challenger.
Good roll program confirmed. Challenger now heading downrange.
At approximately 37 seconds, Challenger encounters the first of several high-altitude wind shear conditions, which last until about 64 seconds. The wind shear creates forces on the vehicle with relatively large fluctuations. These are immediately sensed and countered by the guidance, navigation, and control system.
Engines beginning throttling down now at 94%. Normal throttles for most of the flight, 104%. We'll throttle down to 65% shortly.
The steering system of the solid rocket booster responds to all commands and wind shear effects. The wind shear causes the steering system to be more active than on any previous flight. Mission Control tells Scobie,
Challenger, go with throttle up. Challenger, go with throttle up.
And seconds later, the vehicle disappears in an explosion just 73 seconds after liftoff, at an altitude of 14,000 meters, or 46,000 feet. Debris rained into the Atlantic Ocean for more than an hour after the explosion. Searches revealed no sign of the crew. The immediate cause of the accident was suspected within days and was fully established within a few weeks. The air temperature on January 28 was predicted to be a record low for a space shuttle launch. Challenger was cleared to launch at 11:38 a.m. with an air temperature of 36 degrees Fahrenheit, or 2 degrees Celsius. The severe cold reduced the resiliency of 2 rubber O-rings that sealed the joint between the 2 lower segments of the right-hand solid rocket booster. Under normal circumstances, when the shuttle's 3 main engines ignited, they pressed the whole vehicle forward, and the boosters were ignited when the vehicle swung back to center. On the morning of the accident, an effect called joint rotation occurred, which prevented the rings from resealing and opened a path for hot exhaust gas to escape from inside the booster. Puffs of black smoke appeared on the far side of the booster in a spot not visible to most cameras. As the vehicle ascended, the leak expanded, and after 59 seconds an 8-foot stream of flame emerged from the hole. This grew to 40 feet and gradually eroded one of the 3 struts that secured the booster's base to the large external tank, carrying liquid hydrogen and liquid oxygen for the orbiter engines. At the same time, Thrust in the booster lagged slightly, although within limits, and the nozzle steering systems tried to compensate. When the strut broke, the booster's base swiveled outward, forcing its nose through the top of the external fuel tank and causing the whole tank to collapse and explode. Challenger broke up in the explosion, but the forward section with the crew cabin was severed in one piece. It continued to coast upward with other debris, including the wings and still flaming engines, and then plummeted to the ocean. It was believed that the crew survived the initial breakup, but that loss of cabin pressure rendered them unconscious within seconds, since they did not wear pressure suits. Death probably resulted from oxygen deficiency minutes before impact. The boosters also survived the fireball and righted themselves to continue flying, something totally unexpected. Range safety officers finally detonated their charges 30 seconds later to prevent them from flying over land. After the accident, NASA immediately began work on a redesigned solid booster for future launches.